Industrial Internet of Things, the big picture. First, we'll look at the historical perspective of I 4.0, an overview of the complete IIoT system, discussion of common terms and acronyms, and the manufacturing process. So, the Industrial Revolution really started in the late 1700s and into the early 1800s. And the big things there were transition from manual labor to steam power, and also a transition of building using iron and then steel as opposed to wood and brick. So around the late 1800s, we got to what we call now I 2.0, or the second industrial revolution. And there's three big things that kind of occurred during this time frame. One of those was the idea of mass production, the assembly line, and also the use of electricity. So, with mass production, the idea is that you make a lot of things and that are exactly the same, and so you can piece things together. Before this, things were pretty much kind of built as a custom. Okay, I'm going to build this, and then when you build it for another car or whatever you were doing, maybe there were some differences. So by using mass production, and then especially including the assembly line, where each person has a specific task to get done, they were able to increase production greatly. The other big thing was the use of electricity. So electricity was cleaner, gave you a little bit more control, a little bit more of action of what's happening there. All right. So around about 1969, the first PLC was created, which really produced automation. And so PLC stands for Programmable Logic Controller. And technically, when it was first created, they kind of nicknamed it PC, Programmable Controller. However, in 1980, of course, IBM coined the term PC for personal computer for their IBM personal computer that they brought out. And so there was some ambiguity between a PC programmable controller and a PC personal computer. And so they kind of switched to the name PLC, which is Programmable Logic Controller. Now, this is a controller. It's a computer. It is a computer, but the difference is that it's designed for you to wire it up so that you can actually control, things, primarily for manufacturing. So this is a picture of a Allen Bradley PLC here. And, like say, the big thing here is you can see all these different wires here that are being wired out to the real world. You have contacts of sensors that are wired up, and then actuators, electric motors, or things that you're making happen. So this here at the right is what they call ladder logic, which is a common way of programming a PLC. All right. The other thing is, as we advanced, we've gotten more and more into the automation, including robotics. And so, this is just a picture of manufacturing here, where you have just, hundreds of robots. So, it looks kind of like the assembly line that we saw earlier, only instead of having humans, you have robots doing their designated tasks. Now, one of the things we'll talk about quite a bit in this class is something called real-time control. Okay, and so real-time, there's actually two different terms there. I've got a link down here to the Grammarcist, so you can read about it. But the difference is real time, real space time is technically a noun, and real time, either hyphenated or as a whole word, is technically an adjective. Okay, so but what we're talking about is for things to get done in a timely manner. So the idea is you can, like a lot of times we use the term like, hey, I'm watching the football game now in real time. So we're sitting at home watching it on our cell phone or streaming it on TV or whatever the case may be. And technically, you're not seeing it in real time, right? There's a delay between when it actually occurs and when it actually gets to your phone or your TV. There's some delay in there, but for the most part, that delay doesn't really bother us. Okay. However, when we look at manufacturing or things like that, you can see that things have to happen in real time. So if you see here, you see this is a tank, and that's antifreeze flowing out of the top of the tank. So something happened here where a pump was pumping antifreeze into this tank, and it did not get the message to stop. So typically you would have a sensor up here at the top of the tank, and when the liquid, in this case the antifreeze, gets to the top, that sensor then sends down a message to a controller. That controller then automatically stops the pump from putting any more antifreeze in there, so you don't have thousands of gallons of antifreeze flowing out onto the earth, right? I mean, not only is this a waste of money, this is perfectly good antifreeze that, once it gets contaminated in the dirt, it's probably just going to be disposed of. But, it causes environmental hazards and things like that, so you have cleanup issues. So the idea is that when that tank is full, you need to make sure that the pumping is stopped before you have this overflow. Now, when we talk about real-time control, modern operating systems like Windows, which one you most likely use, Mac systems, Android systems, Apple phones, Apple computers, Linux computers, none of these standard computers are real time. So if you've ever been like on your computer and you're trying to do something and then all of a sudden you're just like, what's it doing? It just seems like it's waiting for something. That's because these operating systems, they're in the background, they're doing other things. And these other things, they don't care about you and or getting things done in a hurry. They're like, oh, I'm going to go download an update, or I'm going to spin my wheels, whatever I'm going to do. And it's kind of an annoyance sometimes when you're trying to get something done and you got to kind of sit there and wait for your computer to come back and start listening to you, but it's not a disaster. On the other hand, as you can see, right, with this tank of antifreeze overflowing out of the top and onto the ground, that's a bit of a disaster there. And so you need to have a real-time operating system most of the time. You can't use something like Windows to control a system when it's important that things happen now in real time. All right, so we've talked about the first three revolutions. So here we are into what has been coined I 4.0, or the fourth industrial revolution. And actually now, this kind of started maybe in the late 1900s. And now we are 25, 30, 35 years later, and some people have even started coining this that we are kind of in 5.0 stages or something like that. But this term I 4.0 was actually coined in Germany, and it wasn't coined all that long ago. But so it's these revolutions, right? These changes are things that are occurring over time, and so you can't just say, oh well, this happened in on January 1st at 3 o'clock in the morning of 2025 or something like that. You can't just specifically state an exact time. They're really things that have evolved over a long period of time. So, looking at I 4.0, there's basically three different areas. One of those is digitization. Okay, so digitizing means that we're just kind of collecting everything, we're putting it in a computer, and tracking what is happening, so that we have a better idea of where everything is at, how much waste we have, how much stuff we have in inventory, all these different kinds of terms. Now, when this was first starting back in the 90s, there were a couple of terms that became very popular back then called CIM, which is Computer Integrated Manufacturing, and JIT, which is just in time. And the idea of just in time was like if you are building a car, you're going to have to put tires on it. So most car companies like Ford, GM, or even Tesla, they don't make tires, right? You have tire companies actually make the tires, so you actually have to like order the tires and have them delivered. So if I'm going to make, say, 1,000 cars today, then I'm going to need 4,000 tires today, or 5,000 if you want to include a spare in that. And so I need those 5,000 tires today. So before this idea of just in time, a lot of times what would happen is, maybe a car company would order, say 50,000 or 100,000 tires and hold them in a warehouse. And then as they build a car, they would put their 5 tires on the car and then move it along. And they always had this warehouse with, hundreds or thousands of tires. But the idea of just in time means that, okay, well, I'm going to need these tires. I only need 5,000 tires today for 1,000 cars. Then I'm going to go ahead and order. And so today I'll have 5,000 tires delivered. Tomorrow I'm going to do another 1,000 cars, so I'll have another 5,000. So you'd get them just in time. The idea there was now I don't have to have a huge warehouse with 100,000 tires sitting in it waiting for me to get to. And so, you don't have a warehouse. You also don't have to pay end of year taxes on inventory you have in your warehouse, things like that. But on the other hand, you run into issues when you have things like, major snowstorms that, block traffic and prevent trucks from delivering your tires. And so, you may be, somewhere, say you're in Tennessee or somewhere, building these cars, and the tires are coming from Akron, Ohio. And even though maybe in Tennessee you really don't have any snow or very little snow, but up in Akron, Ohio, they've got just got dumped on with a foot of snow, and so it's going to take a long time. So the traffic's backed up or basically stopped for a day or two. Now just in time means it's just isn't there. And that was kind of the joke sometimes about this concept of JIT was they kind of called it just isn't there, because a lot of times you didn't have what you needed because it wasn't sitting in the warehouse ready to go. So there's trade-offs. I'm not saying that it's bad, but it's not perfect. All right, another big thing that we see a lot of times today is this concept of AI, or artificial intelligence, and this comes in many different forms. One classic form of this is simply really boils down to a bunch of if statements. So what you do is you basically teach this AI system a lot of different logic, and then it goes through and asks these questions. So you can say, okay, well, if it's November, or in this case January, so if it's November and it's cloudy and we're in Ohio, then guess what? It's cold today, right? So just lots of ifs, and then it just kind of drills down until it kind of resolves to a system. Okay. We also have vision systems. Vision systems are huge in manufacturing, robotics, and things like that. We use camera systems a lot to identify parts, things like that. Neural networks is also, the idea of a neural network is they're trying to kind of mimic the brain, the neural cells in your brain, how things are just, you have all these different cells and it kind of feeds them through. Another one, something called fuzzy logic. So fuzzy logic is like, I did a system for a boat, controlling a boat on the water using a fuzzy logic steering system. So the idea is, if the driver driving the boat turns the wheel really, really hard, then you want to turn really sharp. But if they just turn it a little bit, then you want to just turn the rudder just a little bit, so that you just make a slight turn instead of a hard turn. And so, and then the idea of the fuzzy logic is like, okay, well, what if they're in between that little bit and all the way, so now you're somewhere in the middle. And so it kind of just does some calculations to figure out how much in the middle. Are you closer to the little bit, or are you closer to all the way? Those sorts of things is the idea of fuzzy logic. All right, so let's look at IIoT here. So the idea of IIoT is down here at the bottom. We have what they call field devices. So we're going to be doing various different tasks, and we're going to have motors that are driving pumps. Maybe these pumps are pumping heat out to make a chiller, to, I don't know, make ice cubes or something. As you can see, this particular slide that I have here, this picture came from breweries. So I guess we're looking at like chilling beer or something in that case here. So we're pumping heat away to chill the liquid in here. So we have something called a VFD, which is a variable frequency drive, which controls the speed of the motor. The PLC is controlling the variable frequency drive and controlling different aspects. So we're going to have sensors down here that are sensing what the temperature is, various different things like that. And then the PLC decides, how fast to run the motor to keep the temperature at the desired temperature. But then above that, we have what we call edge computing devices. So the PLC can report up to this edge computing device. That device is on the edge of the internet, and then it's able to then pass that information up through the cloud, through the internet, to other devices like the boss's PC or cell phones or things like that, so that they can get status about what's happening at any time. Okay. So here's a slightly different structure. It's pretty much the same, it just kind of has some different things. So down here we have sensors, actuators, and controllers. Those are being controlled by PLCs or other real-time controllers. So that's one of the big things I didn't mention about a PLC or programmable logic controller, is a real-time computer. So it's a computer designed to interact with the real world, control different things, and it's definitely a real time, meaning that it's going to read the sensor, decide what to do about shutting off the pump, and actually sending the message to the pump and shutting it off, in real time. So it's not going to go on these holidays like your Windows computer does to you sometimes, and you're just sitting there waiting for it, and you can't do anything until it decides to come back and react to your mouse or your keystroke. All right, so from your PLC, then we have something called an HMI, which is a human machine interface. That's like a touch screen sort of computer sitting by the machine so that the operators can give instructions to it, view the status, see what's happening. And then the PLCs and the HMI, they can then send data through this gateway device on the edge of the internet, and then that edge device or gateway device will then pass that information up here to the cloud, where we can store it in a database and we can do analytics and reporting on it and just monitoring the real time actions. But the difference here is what's happening up here is what I call soft real time. So the data, down here you have a sensor that tells the controller the tank is full, and then the controller has to tell it shut off the pump before you got antifreeze flowing onto the ground, right? And that has to happen within a few milliseconds. That's a real-time important thing that you can't just have a delay on. Where up here in the cloud, all we're doing is sending the data up there. And yeah, we might like to have the data right now, but if it gets there 30 seconds or a minute or even 5 minutes later, it's not really the end of the world. As long as the pump got stopped and no antifreeze got to the ground, that was successful. If it takes us 5 minutes before we get the message that the pump stopped up here on our cell phone, that's okay. All right, so the one thing about a class like this is there's just going to be a lot of terminology, right? So you just kind of have to, kind of get used to the terminology and stuff. And so that's one of the probably the most difficult part of this class is just getting used to some different terms that maybe you've never heard. So OT stands for Operation Technology. This is talking about the operation of the machines and stuff in the factory, and so it includes the sensors that are detecting whether the tank is full or what the temperature is or things like that. The actuators are things like motors or pumps, and the motor actually runs the pump, so it's really the motor that's the actuator, or solenoids are things that make things happen or move. Okay, and then IT, of course, refers to computers and network related devices like switches and routers, and we'll talk about these later on in the class in more detail. But so this idea of IoT is the combination of the computers and switches and networking tools with the operation technology. And that, of course, gives us our industrial Internet of Things. All right, so one thing we're going to talk a lot about here is data. Data is information that we're going to collect. We're going to store it in something called a database, the next word there. And then we can process it. We can also transmit it to other devices and see what's happening. Edge device, we've already kind of seen that. Now the edge device can kind of sit in one of two areas. On the one hand, sometimes we refer to the edge devices as the ones down here like the sensors and the actuators. Or we talk about the device that's between our manufacturing plant and the cloud. Okay, so again, there's a little bit of confusion there. Most of the time they're talking about an edge device, they're talking about that gateway device that allows the data to get transferred up into the cloud. But sometimes people are referring to the things that are right down there at the very edge, which are the sensors and the actuators. Okay, so a gateway is a device that allows you to go, technically it's a networking term, it's a device that allows you to go from one network to a different network. Okay. um, a router is a device that routes the information on the network, and a lot of times we refer to a Wi-Fi router, or we just call it a Wi-Fi, which means that it's wireless. Okay. The internet, just in general terms, is a combined connection to many computers out there anywhere in the world. Okay. The cloud, a lot of times the internet and the cloud, they're kind of the same, but a little bit of nuance of differences here. So the cloud is more of a generic term referring to these computer systems that are out on the internet. So the internet is more of maybe the networking. Uh, People tend to think of the internet more of as the networking to be able to get there, and then the cloud kind of refers to those systems that are out there somewhere that we're sending the data to or getting the data from. All right, so a sensor is a device that measures physical attributes such as temperature, pressure, speed, and it converts that into some form that can be read by our controller device. And then we can send that to our edge devices for additional processing, but we're also processing it at the controller device. An actuator refers to something that is actually going to physically make something happen in the world. The most common ones of those are like electric motors that make things move, speakers. If you hear like a sound or an alert or something like that, right? You're moving airwaves. So a speaker is an actuator. Lights are actuators, right? You're converting that electricity into a visual thing. So you're basically, an actuator is going to take an electrical signal from our controller and turn that more into something, some sort of physical movement or some sort of physical action. The controller, of course, is like a device, usually a computer, although it doesn't necessarily have to be a computer, but it's a device that can read the information from the sensor and then convert that, basically runs a program or performs a task that decides how to respond to that. So in this class, for the most part, we're definitely talking about it's some sort of little computer there running a program, reading the information from the sensors, and then sending instructions to the actuators. Okay. Again, a database, technically a database is kind of a storage location in a computer. So you have a database server, which is basically the software running that you can connect to, usually across the network, that then stores the data into specific files on the computer called the database. A server is a computer. I'm not reading this obviously, word for word here. But a server is, we usually think a server as a computer, but technically it's the software that the computer is running. So any computer could be a server, and any computer could be a client. The difference is that the server is the software that's kind of sitting out there waiting for somebody to request something. The client then requests that, and then the server performs the necessary tasks to get what the client is requesting, and then send that response back to the client. A smart device, one of these things, we have things like they call phones or smartphones and things like that. So just in general, a smart device is basically, nowadays, it's running, it's basically a little computerized thing that can communicate across some sort of network to pass information and maybe perform a task. So, smartphones and tablets are probably the most obvious ones, but when we talk about like the sensors and the actuators, they that we were just discussing, they can actually have their own little built-in microcontroller and communicate on the network, so you can talk to them directly. All right. So we also will use the term sometimes called M2M, which is machine to machine. So the idea here is we have two different machines that are passing information back and forth and performing specific tasks, and there's nothing in between. The data is just going from one machine to the other machine. So, for instance, if I had a smart sensor, it could send data directly to a smart actuator and perform that, and so that actuator would be able to say, oh, well, hey, the temperature is this, I need to slow down or speed up or whatever the task is. All right, some other terms. The SCADA. SCADA stands for Supervisory Control and Data Acquisition. So this is kind of like an advanced HMI used up at a higher level, where we're collecting data, ideally in real time. But again, if there's a little bit of delay at this point, it's not actually controlling the pump or whatever. So it's not the end of the world if it's slightly behind. The HMI, we already referred to that. That's a human-machine interface, usually kind of near the machine, where the operator of the machine can see what's happening and interact with it. Again, this doesn't necessarily have to be real time. Anything human related doesn't necessarily have to be real time, because for us, to decide to go over and, press a button to start or stop it, there's going to be delays in that, where you want that to be controlled by a real-time computer that's going to stop it as soon as that sensor has been triggered. A work cell is a closed environment where some sort of work is being performed. And a manufacturing line is a line of these work cells that are put in a line, so the pieces move from one part to the other and you build the car. So it's kind of like the lines that we saw with the robots or the men earlier in the slides. All right, we'll just briefly talk about a couple of different controllers here. There's lots of simple controllers that are out there, and actually a lot of these are even real time. So there's something called the Nano, the Arduino. It comes in the Nano form or a little bit more powerful one. You can get these, you can get the Nano for maybe $10 on Amazon, or you can get like a kit with lots of sensors and other types of devices for many different things that you can do with it here for maybe $50. They also have these ESP boards. These typically work using the Nano or Arduino software to program these, but they're usually a little bit more advanced. So both of these here are ESP boards are available on Amazon. There's this board here, the 8266. This has some I/O built into it, and it also has Wi-Fi and Bluetooth built right into the chip. So there you can see here, there's the chip, and it's got Wi-Fi built right into it. It's a pretty nice little board. You can also get these ones over here, the ESP32. It's basically similar to the 8266, but it's a 32-bit, meaning it's a little more powerful. I think this 8266 is only like a 16-bit controller, not as fast or powerful. The 32 is a little bit more powerful and of a chip. And this particular one here, it actually has an LED screen included with it, so it's kind kind of cool, and only costs about $30. And these are real time. You download a program to these, and they will run in real time. There's also the Raspberry Pi. You may have heard of this. It's been around for a long time. They're maybe about $40 or $50. Okay, these typically run a version of Linux called Raspbian, or maybe it's another version, or I've heard that people even installed Windows on them, but typically these are not real time. Now, there are some versions of real time operating systems that you can get to run on these, or even a standard PC, but the default ones are not real time. All right, so you can see here this Raspberry Pi comes with 40 different pins that have what they call GPIO on them. GPIO stands for General Purpose Inputs and Outputs. So what that means is that you can make, like this pin here, you can make it an output pin, or you can make it an input pin. So you get to choose it based on what program that you need to run and what you want to do with that particular pin. All right, now there's a BeagleBone. This is the board that we're going to use in the classroom, and I really like this. I like the Raspberry Pi. It's and these other ones I showed you also, but this one's very cool because this one here is kind of a cross between the two. So the nice thing about the Raspberry Pi that I didn't mention is that you can get it right on the internet, very easy. You can plug a mouse into it. It's got HDMI. This is a Raspberry Pi 4 here. It has 2 HDMIs. You can actually run 2 monitors off of this. You can have a keyboard and a mouse to it, and you can do a lot of different things with it very easily, but it's not real time. Well, the BeagleBone here, it's kind of like the Raspberry Pi. It runs a typical ARM processor, which is kind of like the ARM processor that the Pi runs, which is really the same one that Android phones run. So it's just an ordinary non-real-time processor, but you can do a lot of different things with it very easily, get to the internet, things like that. But also, what's cool about this board is it has 2 companion processors that are actual real-time processors. So it's actually got a non-real-time processor, so you can do networking stuff very easily. And then it has these dedicated real-time controller units. Okay, so this PRU, I believe, stands for Programmable Real-Time Units. And so you can program those to handle the tasks that must be real-time, and then you can let the general processor, the ARM processor, do tasks that don't have to be 100% real-time. So the other thing I really like about it is it has a lot more inputs and outputs on it compared to, say, the Raspberry Pi. The Raspberry Pi had 1 connector with 40 pins. This has 2 connectors with 46 pins each. So it has a lot more I/O capability. All right, so one thing I would like for you to do is watch Walker's rant. So there's a gentleman, his name's Walker, and he is definitely an expert in the IIoT area and automating companies and things like that. And so he's got this little rant here, and he talks about this. It's very, very good. I highly recommend that you watch it. And he kind of gives us this outline here. I'm going to come back to this, but we need to look at these definitions first. So let's look here. So CRM stands for Customer Relationship Management. This is a database that companies use to kind of keep track of their customers, what their customers bought, what they've ordered, what we need to send to them, what hasn't been sent, all kinds of information about customers. Then we have a different database called Enterprise Resource Planning. This database tracks what's happening as far as the accounting and the purchasing of your like raw materials and the things that you do, and it's used for planning in the company. And then we have this other thing down here, MES, which is a manufacturing execution system. This is kind of like another database that deals with tracking the manufacturing. And as you can see here, it's like, well, why don't we just have one thing? But in general, this is what happens in the companies. And Walker's rant really kind of talks about, how companies go about selecting these and different things. And so, like I say, you really need to kind of go watch that rant. But as you do that, kind of review these terms so you're with them, because he uses these terms here, these acronyms a lot. Okay, we also have a warehouse management system, which is a database tracking, your different things that you've built that are sitting there in your warehouse and you haven't sent yet. Then we have a separate one for shipping database, and then we have one for like sending invoices to our customers. Okay, and so it's kind of a very convoluted system that companies do. Each one of these are different systems, and one of the big goals, and Walker's rant talks a lot about this, but trying to get these things to all interact properly. All right, so we have our customer database, we have our enterprise planning database, and then we have our manufacturing. So this stuff in the red box here, this is the stuff that is in general running inside the plant area, and maybe not all of it, but some of it at least has to have some real time, but it also needs to have a lot of security, which we'll talk about later on. Okay, so like I say, here's a link to this. So please make sure you watch that. You may need to watch it a couple of times to kind of follow and get used to some of these terms that he's talking about in this rant. All right, just a few more terms here and we'll be done. So a widget, okay? So a lot of times, when people are just kind of talking about what are you building, they use this generic term widget, which is just, this like, could be a car, could be a phone, whatever it is that you're actually producing. KPI stands for Key Performance Indicator. This is some sort of measurement that we can use to monitor to see how well our business is doing. Okay, and along with that is this other term OEE, which is overall equipment effectiveness. Okay, so if I have a robot and it's supposed to be doing a task for me to building these cars or whatever it's doing, how effective is this? What is the efficiency of this? Okay, is it really good? And so we'll talk about some other terms like uptime. How long has the robot been running? Is it down? Is it shut off for some reason? Did it break down, or was it shut down for regular maintenance? Various things like that. Scrap. When I'm building something, and I have to like cut it out, how much material did I cut out and is now unusable? Or if I made it but it's no good and so I can't use it, so I'm going to have to make a new one because this one was out of tolerance and turned out to be useless and it was a waste of money. Okay, so these are just, like I say, a bunch of different terms that you have to kind of think about when you're trying to evaluate how well your production is going. So that's the end of this video.